graduation for my seniors, juniors, one more year. Seniors, we made it. Woo! And wider. Woo! Yeah, we made it. Yo, we made it. Yeah, made it. T4 review. Final one. Here we go. Yo, let's go. Go Weaver. Woo! So it turns out that is actually England's, Britain's national anthem. What are we doing? Taking it, stealing it from them for our graduation music, right? That's crazy, right? Who does that? Who steals that, right? What? Yeah, who steals that? Master's degree, get this cool thing. Woo! Okay, so we are looking at T4 right now. And with it's our final review, guys. You made it, you're there. Do you remember how to keep, change, flip? Keep, change, flip, right? What does division become? Division becomes multiplication. So you keep the first term, keep the first fraction, really. And then you change it to multiplication and you flip. Remember this? You remember this. You flip the second one. Nice. There we go. Way-o. And then you do some factor. Little crack. Got a factor like a tractor. So we're going to pull out a 21 in the bottom. Pause me. You know what you're doing. Try it on your own first. Pause me. So we're pulling out a 21 there. We're left with just x squared minus 1. Which in fact can actually factor more. Factor more. So we get a minus and a plus. And if you pull a 6 out of this one, divide by 6, multiply by 6, you get a 2x plus 1. Nice, nice, nice. Pull out a 7x squared, and you're left with just an x minus 1. Beautiful. List the domain expression, domain restrictions. So pull out a 3 now. We're going to pull out a 3. And so when you pull out a 3, we're left with x squared plus 3x plus 1, which I don't think factors more. Interesting. So we have lots of things that x can't equal, in particular 1 and negative 1. Yeah, I think they might have messed up on that one. Maybe, maybe not. Because you pull out a 3 to see what's left, just doesn't look factorable. So we also have 0 from the 7x squared. Beautiful. And whatever this would become, I don't know. 6x squared plus 9x plus 3. What is going on? What is going on with that one? I mean, I guess we could like graph it and see, like, what is that? 6x squared plus 9x plus 3? What is going on there? Let me see here. So 6x squared. Like, yeah, where does that cross? Does it even, I don't even think it has any intercepts there. Oh, I guess it does. Look at that. So just some decimals, I guess. So it looks like it does factor in a very weird place. We factored in a weird place. Yeah. So it looks like at about 1, maybe, maybe not. Second calc, 0. So we got a left bound, enter, a right bound, enter. Guess right about there. Huh. Okay. I guess that guy factors. Interesting. Weird, but interesting. So, oh, did I make a mistake? I think I did. 6 divided by 3 is 2. There it is. Wondering what I was missing there. Okay, now that can factor. So that's going to factor into 2x and x, and then factors 1 and 1. And plus, because 2x plus 1x is 3x. There we go. So that means x can be negative 1 as well, and as well as negative 1/2. There we go. Cool. Okay, what cancels? What cancels? Well, the 2x plus 1s are going to cancel. the x minus 1s are going to cancel. Is there anything else that cancels? A 6, maybe a 6 and a 3, because 6 divided by 3 is 2. So then we're left with a 2 and a 7x squared on the top. Is there anything else that cancels? Let me see. Anything else that cancels there? Let's see. No, not really. I mean, that divided by 3. On the bottom, we still have a, let's see here. So we still have a 21 on the bottom, as well as an x plus 1 and another x plus 1. That's 2x plus 1s. So I guess neither of those canceled. If you divide by 7, that becomes a 3. So 2x squared over 3, x plus 1 all squared, I guess. Right? I don't think anything else cancels there. Beautiful. So do you remember anything to the 0 power is just a 1? Do you remember that? Do you remember if you divide on the top and bottom, you could reduce that? So we have 3 over 15 divided by 5 is 3 over 2. And then if you have a negative, that's going to bring it down and make it positive. And then you're going to combine those, add those together. And then this y, bring it up. So that's going to be a positive y. So that's y to the 6th power on top. Last but not least, that 0 went away, became a 1. And then looking like a negative 1z. That, oh, y to the negative power, that's right. Y to the negative 1, we brought it up. So just z. Beautiful. Nice. So do you remember how to get a common denominator? Common denominator, I'll be back. So if we pull out a 3, we're left with like 3 times x plus 2. And then this is minus and plus. So they both have x plus 2, but then they're missing each other. So this needs a 3 to the top and bottom. And this one needs an x minus 2 to the top and bottom, top and bottom. And now we have a common denominator. Do you see it? Common denominator. So 3 times x minus 2 times x plus 2. Good. On the top, we have 3 times x is 3x. But then we have x times x is x squared. X times negative 2 is negative 2x. 1 times x is 1x. Make sure it's plus, not minus, because you have to distribute that through. And then last but not least, 1 times negative 2 is negative 2. So what do they have in common? What do they have in common? So it looks like we have a 3x, a 4x minus 2x is 2x. So we have an x squared plus 2x actually, minus 2. Right? All over 3 times x minus 2 times x plus 2. X can equal 2 and negative 2. Way-o. Okay, so there is our answer. So remember how to do rational equations? Good. Do you remember that I becomes a negative? Don't forget that. So 2 times 4 is 8. 2 times 5 is 10i. Negative 3i times 4 is negative 12i. And negative 3i times 5i is negative 15i squared. And so an I squared actually becomes a negative 1. And you're going to multiply it with that negative 15. And that's going to become a positive 15. And you're going to add it with the 8. And you're going to get, let's see, 23, 15, 16, 17, 18, 19, 20, 22, 23. So we get a 23. 10i minus 12i is negative 2i. And there we go. Bada bing, bada bang, bada boom. Remember to pause me during our final exam review. Whole numbers multiply with whole numbers, radicals multiply with radicals. 2 times 4 is 8. And then 3 times 3, so 3 times 3 is 9. So we get, again, let me show you that again. So 2 times 4 is 8. 3 times 3 is 9. The square root of 9 is 3. And 8 times 3 is 24. So then, what else do we have to multiply? Well, this whole thing also has to be multiplied with this one. But really, it's just the radical with the radical. So 2 radical 3 times 2, which is 6. So we get 24 plus 2 radical 6. Their answer. You guys getting the hang of these? You getting the hang of these? There's so many that I just need to blast through some of these, right? So 4th root. So that breaks down into what? 2 times 2 is 4, times 2 is 8, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. It's a fourth root, so we need a pair of 4s to come out and play. So that's 2 times 5 is 10. Still have a fourth root of 2 in there. And then all 4 of those come out to be 1x. And then that's y to the 4th, y to the 4th, and then y to the 1st. So that's 2 y's that are going to come out. So that's y squared. So we have 10xy squared times the fourth root of 2, and we still have a y left inside. Yep, so we still have a y left inside as well as a 2 left inside. And there's our answer. Boom. Boom. That's interesting. That's interesting because you're multiplying all the way down. So all the bottom is missing is an 864 and an 865 is all it's missing. So on the top, that's what has it more. So on the bottom we have what? 863, 8 times 862, times 861, so forth. And this also has 863 times 862 times 861. So these will cancel, and all we'll have left on the top is these two. Boom. So then we'll go over here like this. Whoa. And we'll use our calculator, and we'll go 865 times 864. Nice. Oops. Okay, 747, 360. 747, 360. There we go. Boom. Okay, trying to focus on what's going to be on the test. This is a really good one right here, right? Okay, so that's a third root. So we have a third root of 8x to the 4th power, y to the 6th power. And so we got 6y's. We have 1, 2, 3, 4 4s, and we have 2 times 2, 4, 2 is 8. So we need the third root to come out. So that 8 is definitely going to come out. 3 of the x's are going to come out as 1x. And then 2 pairs of y's are going to come out as y and another y. Don't forget inside, we still have an x left. So that's the cube root of x. Boom. Include that in your answer. Include that x in your answer. Include it in there. Nice. Okay, do you remember how to do properties of logs? Remember how to expand and condense? Remember? So division becomes subtraction. So we have log base 10 is what's really happening of 5. And that's times going on, so times. And then we have log 10 of radical x minus log 10 of y to the 4th power. This is actually x to the half power, which power is going to go in front. And, multiplication becomes addition. Remember? Multiplication becomes addition when expanding. 4 comes in front. So we got log 5 plus 1/2 log x. Plus, what do we have also? Plus, we have a 4 in the front. And then log y. Expanded it. Expanded bandit. So that's ln of 4 times becomes addition times becomes addition. So ln of 4, and then 3 comes next, ln of x plus, and then we have ln of y squared, but again the 2 goes in front. Boom. Boom! Do you know how to condense logarithms? Remember how to condense logs? Remember how to condense? Condense these logs. So power goes in front, power goes in front, and we condense them all to one log. And then we have log A times, because addition becomes multiplication, times b squared. Subtraction becomes division, right? Should we change the color for you? Subtraction becomes division, remember, divided by c to the 3rd power, which c to the 3rd power is the same as the 3rd root of c. Either way, we'll win there. Okay, beautiful. Condense it.
Condense it.
So 1/2 can be multiplied through to both of them. I haven't seen one of these before written this way. This is kind of cool. There we go. Beautiful. So then we can put the 1/2 back because we're condensing. Condensing. So we have ln of 2 to the 1/2 power plus becomes times x to the 1/2 power. Good. And then divided by x. And so really that could be listed as the square root of 2x over x. Boom! Yeah, next page. Okay, so solve each equation, exact form, no decimals. There may be extraneous solutions. So get everything on the same side and factor it. Remember how to factor? You remember how to factor. If you don't remember how to factor, you gotta remember. That becomes a 0. Pause me. You stop copying. You pause me to learn all this. You remember. This is a good review for you. It's good for you. So we have 3x and x. We're almost there. We're almost there. Okay, so then factors of 7 are 1 and 7. And 1 times 7 is 21. And so if we have a positive 21, but then we minus 1, that'll give us a 20x. Nice. That means that we set each of those equal to 0. So 3x minus 1 equals 0, and x plus 7 equals 0. Minus it to the other side. We get negative 7. Check if it's extraneous. Add 1 to the other side, so we get 3x is equal to positive 1. Divide by 3. Divide by 3. We get 1/3 and negative 7. Do you remember how to do radical? Radical. Remember radicals? So we're going to add 1 to the other side, so we get 16. This is times, so you're going to have to divide. Don't forget how to do that on our final exam. So we get 8. And then we bring down our 4x plus 12. How do we undo the square root? How do we undo the square root? How do we undo the square root? Do you remember? So we power 2 both sides. And that gives us 4x plus 12 is equal to 64. Minus 12 to the other side. So we get 4x is equal to 4 minus 2 is 2. That's 6 minus 1 is 52. Ooh. So we get 52/4, which I guess you can divide by 2, divide by 2, right? 26 tabs? Does that reduce again? I guess so. Yeah, I guess they're both divisible by 4, yeah. So that would be what, 13? 13! Woo! Nice. So 52 divided by 4, is that 13? I think so. Boom! X equals 13. Good job. You got this. Do you remember how to do radicals where you have like x minus 3? You have to square both sides. You have to square everything on the right side. Everything on the right side. So what does that mean? That means you've got x minus 3 times x minus 3 because there's 2 of them. Distribute it. So x squared minus 3x. There's another minus 3x and negative 9. Negative 3 times negative 3 is a positive 9. So then we have x squared minus 6x plus 9. And we bring that over to the other side now. Let's change some color. So we're going to minus x. So we get x squared minus 7x. Minus a 3. And we get 6. Okay, so what does x squared minus 7x plus 6 factor into? What does it factor into? What do you think? What do you think? What does it factor into? Negative times negative is a positive, so probably 1 times 6. And negative times negative is a positive. Right? So negative 1x and negative 6x is negative 7x. So we get x equals 1 and 6. Woo! So you plug that back in. And when you do, something bad happens. When you plug it back in, you get the square root of 1 plus 3 is 4. And then 1 minus 3 is negative 2. What the? 2 does not equal negative 2. 1 does not work. If you plug a 6 in, that works. Plug a 6 in, you get 3 is equal to 3. And it works. So the 1 does not work, but the 6 does work. Right? Because it says, remember it says, watch out for extraneous. Remember, check your answers. They're Maybe extraneous solutions. So watch out for that, watch out for that, watch out for that. Good. Remember how to condense. Remember how to factor. Remember how to pull out the GCF. I don't think I'm going to have time, you guys, to go through every single one of these, but I'll try to remember the ones that are on the test to help you. I mean, they're all could be on there, but definitely trying to get you, pull out an X. Just trying to get you some help here, right? There we go. So we pulled out a GCF. We got negative 6 the other side. And then we pulled out a GCF, and we're going to factor in more. So probably 2 times 3. Sine middle term goes with a bigger number. Boom. Bigger number. So now we have 3 factors to worry about. 3x minus 2x is 1x. So we have from this guy right here, we have x equals 0. This guy right here, we have x equals positive 2. And this one here, we have x equals negative 3. Way-o. Boop, boop, boom. Boom. Right? There we go. So we didn't have time to condense this. It does condense into 1 log. And then addition becomes multiplication. So that's x minus 4 times x plus 2. And then you have to base 3 to both sides to get rid of the log base 3. So that becomes 3 to the 3rd power, which is 27. Got to FOIL that guy out to x squared. Plus 2x minus 4x minus 8. So that's going to be x squared minus 2x minus 8. No, minus 27 to the other side. Make it big. 27, is that 35? I think that's 35. Negative 35. So then we have x squared minus 2x minus 35. So I'm thinking probably factors into 7 and 2. What do you think? What do you think? Pause me. Try it on your own. Pause me. Try each one on your own. On your own. Okay, so we probably have a sine middle term goes with a bigger number. So we should get x equals 7 and negative 5. So x equals 7 and x equals negative 5 because you change the signs. Change the signs. And can you do log of a negative number? No, you cannot do log of a negative number because that would be log base 3 of negative 5 plus 2 is negative 3. That's not going to work. Not going to work. Definitely going to work. Woo! So try number 20 on your own. Try number 20 on your own. Do you remember how to do these ones? Do you remember? Do you remember? This will be on the test. So this is saying to plug 3 into f. So we have 3 times minus 1. And so we're going to go ahead and plug a 3 in there for f, because that's f means x equals 3. So we plug that in there like this. And then we also have g of 5. And so that's g of x equals 5. And so that's going to plug in here. It's going to plug in there. So then we get, what do we get here? We got a plus going on, so plus. And then we have 5 squared. So 5 squared plus 2 is 25 plus 2, which is 27. 3 times 3 is 9. 9 minus 1 is 8. And 8 plus 27 is 35. Boom. f of x times g of x is just simply taking 3x minus 1 and timesing it with x squared plus 2. I'll let you do that one on your own. FOIL it, FOIL it. Now if it's like this, it wants you to FOIL it, but it also wants you to plug an x equals 2 in there. You could do it all together and just plug the 2 in there, and there, and there, and there, plug the 2 in. Or you could plug them in individually and just times the numbers. So f is 3x minus 1 times g, which is x squared plus 2. And if I just go ahead and plug those numbers in there first, that might make it real easy, because 2 squared is 4, and 4 plus 2 is 6. And then we plug a 2 in here. 3 times 2 is 6, minus 1 is 5. So we're going to times 5 times 6. And 5 times 6 is 30. We got it. So this equals a big 30 there. Beautiful. So g of x minus f of x is just taking x squared plus 2, and minusing f of x, which is 3x minus 1. Don't forget to distribute the negative through. So it's negative 3x plus 1. Don't forget, don't forget. Then you have your x squared plus 2, and 2 and 1 is 3. So we have x squared minus 3x plus 3. Boom. So don't forget g of f of x, take f and plug it into g. So g is x squared plus 2, x squared plus 2. And you're taking f, which is 3x minus 1, and you're plugging it in there into g. So that's going to be 3x minus 1 all squared, which is the same as 3x minus 1 times 3x minus 1. Let you finish that one on your own. Right? You got to FOIL it, FOIL it. So 3x times 3x is 9x squared. 3x times negative 1 is 3x. This negative 1 times 3x is negative 3x. Negative 1 times negative 1 is a positive 1 plus 2. Don't forget to bring the plus 2 down. Plus 3, negative 6x, 9x squared, bada bing, bada boom! F of g is the same as f of g of x. So we're taking now g this time, which is x squared plus 2, and we're actually plugging it into f, which is 3 times x, where x is now gone, and in its place is the x squared plus 2. Remember how to do that? Remember how to do that? And then don't forget at the end of that, there's still a plus 2 in there. No, wait, we plug that in. So it's g into f. So that's a minus 1 at the end. There we go. Distribute it through, so that's 3x squared plus 6 minus 1. So that's 3x squared plus 5. Boom. Thanks for watching. Stay tuned for our next video. Thanks for watching. Bye for now.